In this video, we will go over the troubleshooting tool that the FortiGate has called Debug Flow. So usually when we run a debug flow, we want to understand why a certain traffic flow is behaving the way that it is or not behaving the way that we expect. So maybe we want to have a better understanding of what, if traffic is matching a certain policy or not, or if traffic is being natted or not natted, or how traffic is being routed. So really we want to understand the logic process in the FortiGate and how it applies to a certain set of traffic. So let's go over how the filtering works, and then we'll just get right into some examples. Currently we don't have any filter set. Okay, so now we have the filter set for 8.8.4.4 and protocol 1, so that'll cover our ICMP ping test. Now, if you ever do want to clear that filter and start from square one, which would be this filter above here, go diag debug flow filter clear. Now, since we have our filters set, the next step here would be to go diag debug console timestamp enabled. This just puts a timestamp to every single trace that we see. And then we'll also type in diag debug flow trace start. In my case, I'm just going to do 2. So with this, pretty much you can kind of think of this command as the debug flow command will show us 2 packets, and then it's going to stop the output. So we could, a lot of times you might put in something like 100 or 1,000 so that you can see a lot more traffic. In this case, all I want to do is just see an ICMP echo request go out and then see the reply come back. So then after that, we will type in diag debug enable, and then now the debug flow is live. So now I'll send a ping out. Okay, so you can see that multiple pings are going out, but it only caught the first. It only actually caught the first ping because again we had the flow trace start set to 2. So then you can see below here, this is actually the ICMP echo request, and this is the reply. Okay, so starting with the request, all of these lines of logic are pretty much comprising that echo request that we see. So one thing that we'll note is that the trace ID is 10159, and these are all the same number for the same packet. And then once the reply is received, we see 10160, and again, all of these lines of output with that same trace ID, that's really the FortiGate's logic applying to that same packet. So we can see the source IP, destination IP, source interface. We can see that a session, that number that gets created, this is a unique session serial number. We can see information about the route that was found, and then the gateway that's used, or essentially this is the next hop, and then the destination interface. And what's great here is we can actually see that the traffic was allowed by policy 3 and that there's a source NAT action. So pretty much the source IP 112.4 is going to be changed to 166.166.1.2. So going back to that allowed by policy 3, let's go into the FortiGate GUI. Here, if we filter and include ID, so I just right click the top column and then scroll over here, we can see, okay, this is the policy that was matched, this internet outbound policy. Okay, so back to the debug flow output. Now if we take a look quickly at the echo reply, a lot of this stuff is occurring in the reverse direction, right? So 8.8.4.4 is going to be sent to 166.166.1.2, the WAN IP, received on the WAN 1 interface. This time we're doing a DNAT to find an existing session which has already been matched. So it ends with 3.8. Again, we can see here 3.8 is the first session, right? Because the traffic matches policy 3, but then the traffic in response to the existing session that went out via the echo request, that's going to be allowed back in via the same policy 3. And then, traffic finds a route, and then we send it to the end destination, or essentially the source IP that initiated the initial echo request. Okay, so that was a working example. Now let's take another example of something that might not be working. So let's say now we're trying to do a ping to 20.20.20.1, and this is currently not working, and the destination is accessible via an IPsec tunnel. So we'll just enable our debug flow and then send a ping. Okay, so here we can see that traffic from 112.4 to IP 20.20.20.1 from the internal network, it was allowed by policy 2. So we don't have any type of firewall policy issue. We're able to find a route via a IPsec tunnel called to main site, but then we can see that there was no matching IPsec selector so that the traffic was dropped. So in this case, there was no routing issue, no policy issue. The issue happened to be something to do with IPsec and then matching an IPsec selector. So now if we were to actually go into that configuration to resolve it, we would go to our IPsec tunnel, and then we can see here that there's a phase 2 selector misconfiguration. We don't actually see 20.20.20.1 as any type of destination selector. So, if we were to resolve this on both firewalls, essentially, I won't get into the exact specifics here, but, going 192.168.112.0 and then have, something like 20.20.20.0/24 as the remote address, and doing the same in reverse on the other firewall, then we would solve that issue because the traffic would not be dropped on the IPsec selector anymore. Okay, and here's another example of a non-working environment. Let's say that we've ran a debug flow for 192.168.112.4. Okay, so we're just gonna, in this particular scenario, someone's trying to ping 192.168.112.4, but then that traffic is not actually reaching that destination. So we can run a debug flow. What I'll do then is I'll go onto the machine that can't access 112.4. Let's run that ping. Okay, there we go. We can stop the ping. Pretty quickly we can see actually what the issue is here. So in this particular case, what the firewall is trying to tell us is that there is a reverse path check fail. So what this means is that the source is 192.168.111.9. The destination is 192.168.112.4. The source interface is WAN 2. So that's the interface that the FortiGate receives this echo request from. So, the FortiGate is pretty much, in this case, it's saying, I don't actually have a route back to the 192.168.111 network via the interface that the FortiGate received the traffic from, which is WAN 2. Right? So how we can confirm that in the routing table would be going get router info routing table. We'll go details, and then let's put in information about the source, which would be 192.168.111.9. We're going to say, how do we access that source? Which route in the FortiGate's routing table do we have to access the source IP that we receive the traffic from? In that case, we can see that the route that the FortiGate actually has is via WAN 1. There's actually no route to this destination via WAN 2. So that's ultimately the reason why the traffic is actually not getting forwarded to the destination. Okay, so let's say that we wanted to solve that issue, and we looked into it and realized, okay, WAN 2 should have actually been the destination interface to reach 192.168.111.0. So we would just fix things up. Okay, so we would just fix up the route to actually use the correct destination interface. Now let's resend that ping and see if it's successful. Okay, so as we can see, now when we ran the ping, okay, we're not getting the reverse path check failure anymore, but we are getting another issue. We have a denied by forward policy check. Pretty much, we've hit just a basic issue here where even though we've fixed that routing problem, we don't actually have a firewall policy to allow this traffic. So, in my case, I'm just going to create, a policy to allow the traffic real quick here. Okay, and then let's give it another go. Okay, there we go. So now our ping is successful now. Okay, so that wraps things up. Hopefully this will give you an idea, at least on where to start when you're troubleshooting traffic flow through the FortiGate firewall. A lot of these examples may not apply specifically to you, but again, hopefully the filtering and a bit of the review as to how the basics are on how to read this output will give you a hand. So thanks everyone for joining in, and we'll see you in the next video.